Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so that's it. So question number first. Question number first is a particle of mass m a particle of mass a particle of mass m moves in a potential moves in a potential in a potential that is that is v equal to half m omega 1 x square plus omega 2 y square plus omega 3 omega 3 square. This is omega 2 square and this is omega 1 square. Okay, omega 3 square z square. So this is the potential given. Okay, in the coordinates of in the in the coordinates of in the coordinates in the coordinates of a non-inertial 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 frame non-inertial frame F. The frame F is rotating. The frame F is rotating is rotating is rotating with respect to with with respect to with respect to an inertial frame and an inertial frame inertial frame with an angular velocity angular velocity angular velocity k omega k omega. So this is k cap omega. Okay? K cap omega where k cap is the unit vector is the unit vector is the unit vector along their common z-axis, along their common z-axis, common z-axis, the motion of the particle, the motion of the motion of the particle, the motion of the particle is unstable, is unstable, is unstable for for all angular frequencies, for all angular frequencies, all angular frequencies satisfying 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 options are given. Option A is omega square minus omega 1, this is small omega 1, okay, omega 1 square, okay, and then omega square, omega 2 square, omega 2 square is greater than 0, okay, is greater than 0. And option B is omega square minus omega 1 square, omega 1 square into omega square minus omega 2 square, less than equal to 0, okay, less than equal to 0. Option C is omega square minus omega 1 plus omega 2, whole square bracket into omega square minus mod of omega 1 minus omega 2, mod square of omega 1 minus omega 2 greater than 0. And option D is omega square minus omega 1 plus omega 2, whole square into omega square minus omega 1 minus omega 2, that is mod square of omega 1 minus omega 2 less than equal to 0. Okay, so these are the options, guys. A very good question, guys. I'll explain this question first, and after that I will explain. Okay, so question is, a particle of mass m, okay, so there's a particle of mass m moves in a potential which is given, okay, moves in a potential that is v equal to half m omega 1 square x square plus omega 2 square y square plus omega 3 square z square. Okay, so this is the potential which is given, where in which also particle moves under this potential, okay, in the coordinates of non-inertial frame f. Okay, so it is given in the coordinates of non-inertial frame f. So a particle of mass given in the coordinates of non-inertial frame F. Okay, so the frame F, that is non-inertial frame F, is rotating with respect to an inertial frame. So that non-inertial frame F is rotating with respect to an inertial frame with angular velocity k cap omega. Okay, this is the angular velocity for the non-inertial frame. Okay, where k cap is the unit vector along their common z axis. Okay, common z axis of inertial frame and non-inertial frame. Okay, the motion of the particle is unstable. So the motion of the particle is unstable for all angular frequencies. Okay, the motion of the particle is unstable for all angular frequency satisfying. These are the options given. Okay, so which is the correct option? Okay, for which the motion of particle is unstable for all angular frequency. Okay, so this is the question. Now I will solve it. So first, what we have been given, will write. So we have been given the potential. Okay, potential is given, that is half m omega 1 square x square plus omega 2 square omega 2 square y square plus omega 3 square z square. Okay, so this is what given. Okay, so now we can write in non-inertial frame. Okay, so we can write in non-inertial frame. We can write in non-inertial frame. Okay, so or we can say in non-inertial frame. Okay, or we can write in non-inertial frame, that is x. In non-inertial frame, value of x is going to be minus, because this is the potential. Okay, omega 1 square x in non-inertial frame we can write. Okay, so we can write in non-inertial frame x equal to minus omega 1 square x, and y we can write minus omega 2 square y. Okay, and z we can write minus omega 3 square z. Okay, so this is the one. So this we can write in non-inertial frame. Okay, next is, we have been given that angular velocity is given, that is omega, is given, angular velocity, that is omega is given, that is omega k cap. Okay, so this is given, this is capital omega. Okay, like this, omega k cap. So this is given, angular velocity is given. We have. Okay, next, in non-inertial frame, the acceleration will be, so because it if we talk about a non-inertial frame, so in non-inertial frame, in non-inertial frame, the acceleration will be, there's a formula, guys. Okay, acceleration will be, you need to note down. Okay, acceleration will be a, that a is going to be equal to a naught minus uh, omega cross omega cross omega cross om- omega cross omega cross vector r. Okay, so this is the formula. In non-inertial frame, the acceleration is going to be this one, a equal to a naught minus omega cross r, okay. So this is the formula, guys. Now what we can do, we can just put the values, okay. So this a is going to be this one, a naught vector minus, we'll put the value of omega, okay. So omega value is, that is omega k cap cross omega k cap cross r vector, we know, right? R vector is x I cap, position vector, right? Y j cap plus z k cap, okay. This you need to note down. Okay, so we'll write x I cap plus y j cap plus z k cap. Now we'll simplify it. So a is going to be a naught minus this one. So this is omega k cap from outside, right? And we'll do cross product of these two. So this is going to be omega x k cap cross I cap means j cap minus omega y k cap cross j cap, right? K cap cross j cap is minus I cap. So minus I have already taken, so I cap. And k cap cross k cap, that is going to be 0. Okay. So this vector A is going to be a naught in it is the formula for non-inertial frame. Okay. So a naught minus this one, omega k cap, and this is going to be, again will multiply, so omega square k cross j means j means I cap, right? I cap, and this is going to be this one, okay. This is the one, kj means minus, right? Kj, this is minus minus I cap, so I'm writing minus here, right? Again this one minus omega square y kj, ki is j, right? K cross I is j cap, and this is plus, okay. So vector A is going to be a naught plus omega square x I cap plus omega square y j cap, okay. We can write it. It's very good question, guys, okay. It is non-inertial related problem, okay. So A is going to be, now a naught value we can put it, okay. So the a naught value is this one, because there are only x y, right? A is going to be 0, so this is a naught value is this one minus omega 1 square x I cap minus omega 2 square y j cap, okay, y j cap, and this is plus, this value is going to be this one, omega square x I cap, omega square x I cap plus omega square y j cap plus omega square y j cap, okay. Or we can write a vector A value x I cap plus y j cap, and this is going to be minus omega 1, we can put like this, right? So this is going to be we'll take this common, so this is going to be this omega square minus omega 1 square x, we can take common, okay, minus omega 1 square x plus omega square minus omega 2 square into y j cap, and this is I cap. Okay, so from here we can get value of x, that is omega square minus omega 1 square, and value of y is omega square minus omega 2 square. Okay, omega 2 square into x into y. Okay, this one. Now for unstable motion, guys, this you need to know. For unstable motion, for unstable motion, for unstable motion, that omega square minus omega 1 square, omega square minus omega 1 square, that should be this one, that should be greater equal to 0. Okay, that should be greater equal to 0, and also this one, omega square minus omega 2 square, also should be greater equal to 0. So that implies omega, that implies omega square minus omega 1 square into omega square minus omega 2 square, that must be greater equal to 0. Okay, because this is 0, this is 0, means their product is also 0. Okay, so which option is matching, guys? Let me check which option is matching. Option B is matching, guys. Option B, right? So omega square minus omega 1 square, omega square minus omega 2 square is less than 0. Any mistake we have done? Okay, so this one, this should be greater equal to 0. So let me just check. Omega 1 square. Yeah, that's correct, guys. So option A is the correct option. Okay, this one, not B. So omega square minus omega square minus omega 1 square, and omega square minus omega 2 square should be greater than 0. Okay, so this is the correct option, that option A. Next question, guys. Next question. These are part C questions, guys. So you need to practice those questions, these questions. Okay. Next question is, it is a good question from atomic and molecular physics. The question is, a 60 cobalt, a 60 cobalt, a 60 cobalt, a 60 cobalt nucleus, 60 cobalt nucleus, beta decay, beta decays. Okay, so a 60 cobalt nucleus beta decays from its ground state. Okay, beta decays from its ground state, from this cobalt. Okay, from its ground state, from its ground state, from its ground state with Jp. This is parity and this is total angular momentum. Okay, Jp equal to 5 plus, to a state, to a state, to a state of 60 nickel, 60 nickel with 60 nickel with Jp equal to 4 plus. Okay, from the angular momentum selection rule, from the angular momentum, from the angular momentum from the angular momentum selection rule from the angular momentum selection rule from the angular momentum selection rules, the allowed values of the allowed values of the orbital angular momentum of the orbital allowed values of the angular momentum orbital angular momentum angular momentum L and the total spin S and the total spin S of the of the electron antineutrino electron antineutrino electron antineutrino antineutrino okay. So the total spin S of the electron anti-neutrino pair, okay, anti-neutrino pair pair R, okay. Options are option A L equal to 0 and S equal to 1. Option B is L equal to 1 and S equal to 0. Option C is L equal to 0 and S equal to 0. Option D is L equal to 1 and S equal to 1. Okay, so this is the question, guys. Very good question. I'll explain this question and after that I will solve it. Okay. So question is a 60 cobalt nucleus. Okay, a 60 cobalt nucleus beta decays from its ground state with Gp equal to +5. Okay, so there is a 60 cobalt nucleus which is in its ground state with Gp equal to +5 from where the beta decays, okay, to a state of nickel. So it decays into a state of nickel Ni with Gp equal to 4+, okay, spin parity. From the angular momentum selection rules, the allowed values of orbital angular momentum L and the total spin S of the electron antineutrino pair are. Okay, so so we need to find out the angular momentum and the total spin of electron antineutrino pair are. Okay, so very good question. I'll solve it. Okay. So we have been given this. Okay, so we have 60 cobalt, okay, that beta decays because of beta decay, so it goes into 60 nickel state, and that beta minus gets released, right? It is a beta decay plus antineutrino. Okay, so this is the reaction, guys. So what happens is 60 cobalt in 60 cobalt beta decays, and because of that we get nickel 60 nickel beta negative and antineutrino. Okay, so this is the reaction. Okay, now you can see here very important thing. Okay, this one. So we have if we talk about J value is 5, right? J value is +5 plus Jp value, and here Jp value is for nickel, the Jp value is 4+. Okay, so it means from here is J values, right? J values for this is and this is J value, right? Because it is given in the question, right? J value. So that implies delta J value is going to be delta J value. Delta J value is going to be plus minus 1. Okay, so that comes. And also we can see there is no change in parity, right? So there is no parity is plus and plus, right? So delta pi is equal to no change, right? So no change in parity and delta J equal to plus minus 1 we can see, right? That comes in plus minus 1. So means because so delta J is going to be plus minus 1, right? So it means we can say this one, because this is the condition for delta J equal to plus minus 1 and there is no change in parity. That is the condition for Gamow-Taylor transition, right? So I can write so the given transition is the given transition is given transition is allowed given transition is allowed Gamow, it's Gamow type, okay? Gamow. This pronunciation is Gamow, okay? Gamow, okay? So allowed is so the given transition is allowed Gamow-Taylor transition, okay? Gamow-Taylor transition, Gamow-Taylor transition, Gamow-Taylor transition, Gamow-Taylor transition. So allowed values of allowed values of the orbital angular momentum of the orbital angular momentum L and total spin of electron antineutrino pair are L equal to 0 and S equal to 1, because here delta J equal to plus minus 1, right? And pi there is no change, means so the given transition is allowed Gamow-Taylor transition, okay? So it's a allowed Gamow-Taylor transition. So allowed values of orbital angular momentum L and the total spin of electron antineutrino pair are obviously L equal to 0 and S equal to 1. Okay, so which option is matching, guys? Let me check. Option A is matching. So option A is the correct option. Okay, L equal to 0 and S equal to 1. Okay, guys. So next question. Question number third. Question third is, it's a good question, guys. A satellite of mass m, a satellite of mass m, orbits around mass m orbits around earth earth, okay, orbits around earth in an elliptical trajectory, in an elliptical trajectory of semi-major axis of semi-major axis A at the radial distance r, at at a radial distance radial at a radial distance r equal to r naught, okay, measured from the center of earth, measured from the center of earth, from the center measured from the center of the earth, center of the earth the kinetic energy is the kinetic energy is the kinetic 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 energy is equal to equal to half the magnitude of total energy, okay, half the magnitude of the total energy the total energy if m denotes if m denotes m, if m denotes the mass of earth, denotes the mass of earth and denotes the mass of earth, okay, the total energy and the total energy the total energy total energy the total energy is minus 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 gmm minus gmm upon 2a, the value of r naught upon a is nearest to a is nearest to nearest a is nearest to, okay. So options are option A, that is 1.33, option B is 1.48, option C is 1.25, and option D is 1.67, okay, 1.67. So these are the options, guys. Very good question. I will explain the question first, and after that I'll solve it. Okay, so question is, a satellite of mass m orbits around the earth. Okay, so the satellite is orbiting around the earth in an elliptical trajectory. So in elliptically it is orbiting around the earth, okay, of semi-major axis A, or whose semi-major axis is given, that is A, at a radial distance, r equal to r naught, measured from the center of the earth, which is measured from the center of the earth. Okay, the kinetic at the radial distance, the kinetic energy is equal to half of the magnitude of total energy. Okay, so kinetic energy is equal to half of the total energy of half of the magnitude of total energy. So kinetic energy is half of the total energy. Okay, that is what given. If m denotes the mass of the earth, okay, m denotes the mass of the earth, and total energy is given. The total energy is minus g upon 2a. The value of r naught upon a is nearest. We need to find out value of r naught upon a. Okay, so this is the question, guys. Okay, I'll solve it now. So what we have been given, so we have been given that total energy. Okay, so first we'll write whatever we have been given. So we have been given total energy. Total energy I'm writing short. Okay, that is T I'm writing. Okay, so total energy is, this is minus g mm upon 2a. So this is given. Okay, in the question this is given. Okay, this is the total energy. So minus g mm upon 2a. M is the mass of earth and small m is mass of particle upon 2a. A is the semi major axis of the elliptical orbit. Okay, so the total energy is given, guys. Now, as per the question, according to question, we have been given kinetic energy. That is kinetic energy is half of total energy. The magnitude of kinetic energy is half of total energy, right? So this is what given. Okay, so we can write kinetic energy is going to be this one 1 by 2. This is what given. Okay, in the question. So this is 1 upon 2 kinetic energy. Okay, so this you need to understand. It is written. The kinetic energy is equal to half of the magnitude of the total energy. Okay, so that's why we are taking that mod. So this is going to be 1 by 2 gmm upon 2a, right? Or we can write this value is going to be 1 by 4 gmm upon a, right? This is the one. So now we can find potential energy. Potential energy is total energy minus kinetic energy, right? So this is going to be total energy. We have this, right? This one total energy. So minus g mm upon 2a. This is the total energy minus kinetic energy. Kinetic energy is this one. So 1 by 4 gmm upon a. Okay, we'll solve it. So potential energy is going to be PE is going to be, if you solve it, so this is simple calculation, right? So this is going to be minus 3 gmm upon 4a, sorry, upon 4a, right? 4a. Just simple calculation, we have taken 4a as a LCM and cross multiplied and got this value. Okay, simple calculation. So this is P is minus 3, G is gravitational constant. Okay, okay. So this is the one, the potential energy. So, and we know the potential energy at R equal to R naught. This is important point, guys. Since we know the potential energy potential energy potential energy at r equal to r naught, radial distance, potential energy at r equal to r naught will be, this we know, guys, will be at radial distance, potential energy is going to be minus gmm upon r naught. Okay, so potential energy at r equal to r naught will be this, right? and this is the potential energy also at R equal to R naught, means both will be equal, right? So it means it means it means both will be equal. So it means minus 3 GMM upon 4A, that is going to be equal to GMM upon R naught. Okay, this is the potential energy at R equal to R naught, and this is the potential energy at R equal to R naught. That's why both are equal, right? Okay, now we'll solve it. This GMM, this will get cancelled, right? And this is minus, so minus minus will get cancelled. Okay, that implies value of this one R naught upon A, right? R naught upon A, that is going to be 4 by 3, or that is 1.3. Okay, so this is the value of R. So which option is matching, guys? Let me check. Option A is the correct option, right? We need to find value of R naught upon A. So R naught 1.33. So it's a good question, guys, and you can see it's a simple question, but it's a 5 marks question, guys. Okay. Okay, guys. So this is the one. Okay, guys. So I'm going to stop here today, and also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay. Okay. And also, guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay. Okay, guys. Thank you so much. Bye now.